Today on my channel we shall discuss about electric discharge machining process. So today we will discuss about introduction to electric discharge machining process. To study about its construction, to study about its working principle, and to discuss about its application advantages and disadvantages. So what is electric discharge machining process? Electric discharge machining process is non-conventional machining process. The metal removal takes place due to the erosion caused by the electric spark. This process may be used for machining any conductive material irrespective of its hardness. The rate of metal removal and resulting surface finish can be controlled by proper variation in the energy and duration of spark discharge. A liquid dielectric like paraffin or some light oil like transformer oil or kerosene oil is always used in this process. From this well-illustrated diagram, we will discuss about construction of electric discharge machining process. So, as we can see over here, tool is connected to the negative terminal and workpiece is connected to the positive terminal. Hence, tool acts as cathode and workpiece acts as anode. The gap between the tool and workpiece is known as spark gap. It is about 5 micron. This spark gap is controlled by the servo controller. Hence, the vertical feed of the tool is controlled by the servo control. This reservoir is used to collect all the debris generated due to the machining process. This is the strainer which avoids the flow of debris into the low pressure pump. Hence, the dielectric is supplied into this reservoir after passing it from the strainer and filter. Hence, the dielectric is passed into the tool by the high pressure pump. Hence, dielectric is supplied between this spark gap. So, let us discuss about working principle of electric discharge machining process. With the application of voltage which is about 50 volt to 450 volts, electron starts to migrate from cathode to anode. Hence, electric field builds up between the two electrodes and position of least resistance. The ionization leads to the breakdown of dielectric, which results in drop of voltage and beginning of flow of current. A column of vapor begins to form and localized melting of work commences. The discharge channel continues to expand along with the substantial increase of temperature and pressure. When power is switched off, current drops, no further heat is generated, and discharge column collapses. A portion of molten metal evaporates explosively or ejected away from the electrode surface. With the sudden drop in temperature, remaining molten and vaporized metal solidifies. A tiny crater is thus generated at the surface. The residual debris is flushed away along with the products of decomposition of dielectric fluid. So let us discuss about applications of electric discharge machining process. It is used for the production of die for the fabrication of all components. Electric discharge machining process can be used in manufacturing of hydraulic valve spools, gear, fine holes or slots in hard blade material used in gas turbines, compressor and diesel engine. So let us discuss about advantages of Electric discharge machining process. Electric discharge machining process is a method of machining part that cannot be done by conventional machines. Since the tool does not touch the workpiece, there are no cutting forces generated. Therefore, very fragile parts can be machined. The shape and also the hardness of materials being used make EDM ideal. So, let us discuss about disadvantages of electric discharge machining process. The slow rate of material removal. Electrically non-conductive materials cannot be machined by using this process. Excessive tool wear occurs during the machining process. Power consumption is high. Reproducing sharp corners on the workpiece is difficult due to the electrode wear. Thanks for watching. Please like, subscribe and share my video.